morning to all of you. It gives me great pleasure to add my welcome to you to the first day's proceedings of the National Productivity Summit 2020. What better way to kickstart the presentations at this National Productivity Summit than a keynote address by one of the global experts in quality management, Dr. Gregory Watson. He is going to deliver his keynote talk on managing breakthrough change for productivity and profit. Dr. Watson is past president and honorary member of both the International Academy for Quality and the American Society for Quality. Dr. Watson is the only Westerner to have received the W. Edwards Deming Medal from the Union of Japanese Scientists. He was named honorary member by 20 national quality associations. Dr. Watson has delivered over 600 speeches, master classes, and papers, and written 12 books. Dr. Watson, we are thrilled to have you with us today and to hear your thoughts on managing breakthrough change for productivity and profit. I now cordially invite you to deliver the keynote address, which I am sure will provide a great learning opportunity for all of us. Dr. Gregory Watson, please.
Thank you for inviting me to talk to you today at this National Productivity Summit in India. I would like to speak to you about managing breakthrough change for productivity and profit. And there's 5 topics I'd like to discuss with you. The first is the idea of disruptive change and breakthrough technology. Then we'll talk about current breakthrough technologies to consider that are coming out of this digital age, what's called Quality 4.0. Then I'd like to review a case study that I actually did when I was working at Hewlett-Packard, which is about the digitalization of injection molding. Then we'll go through some lessons learned from other historical endeavors, and then finally recommendations for embracing technology shifts. So what creates industry disruption? Clayton Christensen said the reason why it is so difficult for existing firms to capitalize on disruptive technologies is that their processes and their business model make them good at their existing business activity and make them bad at competing for the disruption. In other words, they've been tuned for the old way of working, and that's what they're used to. That's where they have reinforced their good ideas about themselves and they feel good about. But they feel incompetent about embracing the new technologies. So what are the causes of disruption in productive systems that we're looking at today? Well, first we have interruptions in the flow of materials, parts, or assemblies. And I'm sure you've all experienced those types of things. Next, we have poor communications of plans or production requirements. And I think also you probably have experienced that when you don't exactly know what the customer wants, or you don't exactly know what the materials are that you're processing. And then we start seeing there are issues in the production machinery or the system software, and it's not operating the way we think it should or giving us the results that we need to get. Then there might be shifts in customer demands or economic conditions that will have some external effect on us. Then the fifth is their production status monitoring and timely reporting. We don't have it. We don't really know what's going on in the production system because we don't have that up-to-date inventory of what's happening. So we don't see the data flows. Another is there's an ineffective adaptation of the new technologies or systems. We know what we'd like to do, but we don't know how to actually implement it because we don't have the experience in using those tools, methods, or systems. And finally, there are some natural environmental occurrences or active natures that can create change in our systems. I live in Finland and we always worry about snow in the coming months. I know you don't worry about that in India, but maybe you worry about the cyclones. So are breakthrough technologies emerging? So we see that there's some advanced technologies that are proving more affordable to SMEs. Now, we see artificial intelligence, machine learning, big data, deep learning. These combine to create control systems by enhancing adaptive management of dynamic shifts in supply, demand, and technology requirements. We see 3D metal printing and injection molding technologies allow rapid prototyping and increased microstructural control of metallic compositions. We see internal wireless networks permitting increased technical connectivity and communication technology around factory-wide sensor systems to improve end-to-end production control and enhance communications with both suppliers and with customers. And then finally, we see digital sensors are becoming more accurate, inexpensive, and readily integrated into current production equipment. In the case studies that you'll see today, you'll see many of these technologies actually being brought to the field in terms of applications within Indian SME industries. So, which breakthrough technologies apply? What can be done to control information and streamline flows? Well, we can make investments in information communication technology, what we call ICT. And this is using internet-based search engines and recommendation systems to increase our understanding of customer needs. It's also increasing the bandwidth and processing power of the digital communication links, which enhances our computer response for automated ordering system or for tracking products as they're out in the logistics cycle chain. We can also have investments in production operating systems, POS. And so here we're talking about embedded sensors that are in process data monitoring. Or maybe we're consolidating factory wireless technology and data flows. Or we're doing diagnostic control loops to adjust production equipment based on digital signal processing. Or maybe we're automating the flow of material and storage management. So all of these are different things that are available to us to do today. And we see technology paths for SME manufacturers. We should think small, or start small, think big, but begin with the end in mind. What is the design of the system we'd like to have? So begin by placing digital sensors to monitor production at critical control points. So maybe we use RFID chips to determine location of critical components, or timestamps of barcode codes to determine where systems are as they advance through production, or motion detection to warn of unsafe situations, or vision systems that use pattern recognition to check on identification or completeness of work, or sensors that detect temperature, vibration, weight, etc. in terms of our items that are in the process of production. We can add wireless network to collect digital signals from around the production operations and route them to an internal data cloud for processing. We can add alerting systems or alarms that warn of out-of-control situations based on that data that's been collected, and tell the process operators that you have a situation that's out of control or that needs their attention. Now, don't invest if you'll not be able to demonstrate the actual operational and financial benefits. I think this is a critical ingredient. Don't overinvest. Don't invest too early, because we don't have that much money in an SME to invest in these sorts of technologies. Now, the good news is that we've gone through just this last pandemic, we have production now under control. Many times companies will find that they have excess production today. So investments do not need to be made in extending production capability. So we can use that money that would normally use for production equipment in terms of investing in the digital technologies to advance our control over those systems once we ramp up again after coming out of the COVID situation. Now, I'd like to share with you a case study that illustrates how this can be done based on work that I did at Hewlett-Packard. And this was designing a lean technology system that had payback in less than 6 months. As a matter of fact, you'll see it was just 1 month. So the situation was we needed to perform injection molding of gears. And these were gears for very high, tight tolerance printing systems. And we needed to have 22 mold changes a day, 22 different molds. And the current time at the start was 4 hours for a mold change, just a little bit less than that actually. And so we had a project team, one industrial engineer, that was myself. I had 2 recent graduates of engineering programs, a mechanical engineer and electrical engineer. And then we also had Sal, the molding shop line leader. And we implemented this in less than 3 months. And so we see the resource requirements. What does it take? Well, we were given a electronically automated controlled molding machine. It was just new at that point in time, a Nissan machine, and a budget of less than $100,000. And this was basically, we're looking at this happening back in the 1985, 1986 timeframe. And the technologies applied, we had a blended approach. So if you take a look at where do you start with lean, one of my senseis in Japan, Koichi Kimura, who's the head of the Factory Management Institute, he says start with setup time reduction. Don't start with 5S, don't start with anything. Setup time reduction, because that gets rid of waste in the flows. It allows the flows to move without having waiting time. It frees up productivity time. So we took a blended approach. We were using material science in terms of how we were moving these parts. Previously, these parts were not injection molded. They were all made out of aluminum. And so we were changing them to a polycarbonate with fiberglass and carbon filling. And so we were going to have an engineered plastic. We also had lean production flow. How do we make sure we get the flow of the materials, the parts, to the production line? Our rule was going to be mold today what we use tomorrow, so it would be dimensionally stable. We used single minute exchange of die and changeover thinking to reduce the setup times. We had to test the rheology, or the shrink rate of the plastic, to make sure we understood what the shrink rate would be after it came out of the hot mold. We used pneumatic clamps to hold the molds in the molding machine. We had fixed guides that were put on the machine and on the tools so that they would just slide in place. We had snap fit heating and cooling lines so they would just snap on. And then we had preheating racks to make sure that we put a hot mold into the machine and didn't heat it inside the machine. And we had a small positioning crane to move the molds from the hot rack into the machine. So what was the cost benefit of this system? So the investments, it was about $2,000 per mold, and so it's $44,000. The rheology testing equipment for the lab was $12,000. The injection molding machine modifications for the one machine was $8,000. The offline molding rack was $5,000 for the heating systems, and then the offline manual positioning crane was $9,500. So that's basically less than $80,000 at that time. Now, those prices are actually less today. And the benefits, reduction in part cost was about 6 cents a part. Now we're talking about 22 different parts going in there, and we had 10,000 of those in the first month of production. So we're talking 13,000 from part cost reduction. We also had a reduction in setup time, and we were charging at that time $50 an hour for productive time, and that's $80,000. So basically in less than 4 weeks, we got the payback for that machine. So here's the question. Where do we have hidden capabilities in your factories to do similar sorts of things? And I'm convinced if I look in an SME shop that I can find exactly those sorts of situations. Where can we take just a small amount of money with the right type of equipment and then make it much more productive? So we have also lessons learned from enterprise resource programs that have been put into different companies. So many SMEs have put these in to understand how do we manage our material flows and synchronize them with the order flows. So first, what we have to do is map our process. Don't buy the equipment, understand your process. Know the measures and how you determine and analyze that data and what reports are necessary. So specify the master data items before you begin the software project. What data will you keep in the software? How will it be structured? Where will you store it? How frequently will you sample it? And then assign some operational experts to audit that software process model and validate it against the real world. So when you put a model in the system, how it's going to flow, how you measure it, you have to check to make sure you go to the gemba, as they say in Japan, genichi genbutsu. Understand that process is actually the one that you're doing. Because the software system is acting like a digital twin. It's the twin to the real world system. And what we want to be able to do is to monitor how that real world system is working in the software. And then we need to integrate these data collection points and maybe use barcode scanners to assure that this ERP system has a tracking capability and can actually track the flow through your system. So it understands the material movement as it goes through the production system. And then finally, only produce those reports that have a legitimate need for management. So give management the information they need, high integrity, good fidelity in terms of the quality of the information, and make it sure that it's frequent enough to capture changes in that system that may affect the quality of the output or reduce the productivity of that output. We also see that there's some lessons learned from early robotics use. And here we see that the initial robotics investments were typically pick and place machines. I'm going to pick something here and move it there. And I remember going to a factory and I saw 3 of those pick and place machines on one production line. And guess what? 2 of those were not even necessary. And the third one, I could have done a sorting system manually just with a barcode scanner and a little change in software and not have the whole cost of the robotic machine. So having robots is great, but do you really need them? So can you actually create the system flow so that it flows smoothly? So make digital automation a strategic investment, not a skunkworks project. Not we want to have a robot because having a robot is cool and we look like we're high tech. So avoid this inclination to automate everything. So automate simple processes first where you can get a benefit, where it's too repetitive or dangerous or tiresome for humans to be able to do it. And those are tasks robots can do very quickly. So in the automotive industry, one of the things they first did was automated welding machines or robots, so that the welds could always be done at the right level and quality as all day long without worrying about changing that quality, because the robots would always do what they were programmed to do, whereas people, we get tired and we don't hold that quality. The key question is, are you automating the high precision tasks that workers must repeatedly produce frequently, that would lead to creation of human errors? So we're eliminating errors in the system by the way we automate those productive processes. So the principle should be, let the machines do what human operators consider to be difficult, demeaning, or demanding. Advanced technology can extend this to creative work when we start thinking about applying it for decision making. So evaluate the reason of why are you automating each device. Does it need to be done? Can it be done more simply? Have the processes been simplified and streamlined before deciding to automate them? Be sure not to automate the production of waste or to embed process inefficiency in robotic equipment productions. Now, the critique of digitization efforts of SMEs. We see that in looking at these in the past, there have been some classic mistakes made by SMEs in technology acquisition. So the first is failure to design the productive system so it fits your operational requirements. Do you really need that robot and its capability? Is it actually giving you a benefit that you can say, we are now operating in a way that is more productive than what we were doing before? There's another second one is there's a lack of internal engineering support, which leads to design and production outsourcing the automated assembly. So we give it to another company, say, please design it for us. And I've seen this as being a classical problem. One company went bankrupt because they did this. Another company was not able to actually see the productivity gains they had because the company they gave the design to was more interested in maximizing their engineering value and maximizing their costs and putting really cool technology in that the company didn't need. And so it actually never received the productivity level it operated that it needed to have out of that system. And when they came back to buy more productivity, they had to buy the same system because they were painted into a corner because of regulatory demands imposed by the Food and Drug Administration. So they couldn't even upgrade and streamline the system and make it more inexpensive. Now, purchasing a large specialized machining center we should not do those, but we should have a less sophisticated system that satisfies the need without encouraging overproduction so we get the investment payback. So it's critical that we don't put too much money into one piece of equipment. If you take a look at Toyota, we don't see big machining centers there. What we see is dedicated pieces of equipment at the spot doing a particular task. Less expensive equipment, not more expensive equipment. And then we let the machine do what it needs to do and the human have their part supporting that machine. Incorporating advanced technology to assure management bragging rights is another problem. Or to say we have a marketing position, we're high tech in our industry, or we're first with this technology. So those systems, if they don't add value, that's empty marketing. It's just saying we have now some hot words we're going to talk about. We want to give this marketing pizzazz to our company. But that doesn't help us in the productive world. So we need to make sure that we're actually getting value addition out of those production investments. And perhaps the last one is not investing in necessary technology due to fear. And this is where we say, I don't really know what to do with this and I'm afraid to do this, so I'm going to do nothing. Doing nothing is a choice. And when we make that choice, what happens is we can fall behind. So the best situation is really know your situation, understand what it takes to drive forward, and then invest slowly and surely in what you need to do to drive forward. So I want to give you a checklist, if you will, for adopting new technologies. So carefully ration your investments so they support your needs. So know your production process. Keep the application of automation targeted on simplicity of design. Create a technology adoption team that are cross-functional, that include non-technologists as users to assure adoption of recommendation systems and pragmatic introduction of these capabilities. Identify where you have pain points in your production process, where adoption of technology will give you those tangible benefits. And don't get fooled by the hot application somebody's trying to sell you or the technology of the day when you're going out to buy a system. Take the time to really investigate and make sure that it is right for your application process in production. And then finally, plan carefully the sequence of technology introductions and pay attention to the needs to have synchronicity in the flow of materials with the flow of the ordering information system. Don't let one get out of sync with the other, because at the end of the day, you have to blend in your final system the flow of the orders, the flow of the material, and the flow of the pace of production or the cadence of your production. If those flows become discontinuous, then you'll have failure in your production system and you will not optimize the output. So I have a couple of takeaway points that I'd like to share with you today. So when we think about this, there's some things that are important in terms of a small business. First of all, you don't have much money to invest. That's clear. Even large companies are very careful about how they make their investments in digitization. And we can't make too many failures in these types of things because there's just not any extra money available to cover up for those mistakes. A second issue is that we have to make sure that we get the quality right in those parts. So what we should see at the end of this investment is not just higher productivity, but we should see higher quality results in terms of what we're doing. Less defects, less rework, more on-time delivery to the customers. And so when we start looking at disruptive technology, we have to remember, it is coming to your industry. No matter what your industry is, it is coming. It's probably already there. You may have some leading competitors, or maybe it's a major corporation in India that's already doing this in their internal shop. So either you can be a leader and gain advantage, or you can be a follower and lose advantage. So do not spend time resisting that technology. Carefully make the plan, move it step by step, and be sure that you make each step with confidence. The second point is begin this process of digital transformation by starting in those small steps, getting accustomed to a few simple types of applications. So don't jump in where angels fear to tread. Don't say, oh, I'm going to have neural networks with machine learning and deep learning of big data systems and so forth. Step by step, walk the 1,000-mile road. That's the advice of the Japanese when it comes to how do you make change happen in a major system. And then the third thing is know your processes. Simplify what you're doing. So as you start taking a look at where you're going and understanding what needs to be done, you can automate the process one step at a time because you find the pain point and you work on that pain point. Never automate any process that has not had the waste removed and that's not been streamlined and simplified. Otherwise, you're going to automate production of waste more efficiently. So get the process right. Understand it. Simplify the process in terms of removing waste, getting rid of the cycle time, getting rid of bad parts and quality problems in the material flows, and then synchronizing those processes together. So step by step, walk the 1,000-mile road. So thank you very much for your attention. I know you're going to have some interesting case studies to take a look at now, and perhaps you'll see some of the things that I've been talking about in this presentation in those case studies in real-life examples. So have a good day.
Thank you very much, Dr. Watson, for a very insightful and informative presentation. Your keynote address has clearly brought out the importance of having to quickly adapt to the changing technology landscapes, particularly in digital transformation and automation in all spheres of manufacturing. On behalf of IMTMA and everyone present here, I thank you, Dr. Watson, most graciously for being with us at this summit.